Hello everybody, my name is Petrit and I'm presenting you my paper Agent-Based Modeling for Urban Neighborhoods Energy System, a literature review and a proposal for an all-integrative ABM approach. I don't write this paper alone, I've done this with my doctoral supervisor Irene and Jan Sudeikant. There are defined climate targets for the building, electricity, heat and mobility sectors up to 2045. The integration, electricity, heat, supply and mobility in neighborhoods is essential because in densely population areas all three sectors interact and thus offer synergies in improving efficiency and renewable energy integration. For that, urban planners and architects have several conventional modeling and planning tools available for neighborhood energy systems. The increasing complexity of planning that requires the integration of economics, ecological and political aspects poses a challenge to traditional planning and modeling techniques. Here, could agent-based modeling offers an opportunity. Because of that, that was my main motivation, is that I'm doing a PhD thesis with the title The Neighborhood as a system service provider for the energy transition, operating concept analysis of planned parks for the provision of grid services up to self-sufficient using a coupled simulation systems. And in this context, this paper is a starting point for me for the literature review, and I would like to focus more on ABMs, and the ABMs should include buildings and households or local electricity like power supply, battery or demand, the sector coupling to the heat side and also the sector coupling to the mobility side. Based on that, we had three main research questions that we identified and that we want to look into it more in detail for this paper. The first one is, how was ABM utilized in the energy sector of electricity, heat and mobility in neighborhoods? Which market mechanism, policies and services have been considered? And the last one was, which ABM platform are used for the implementation? To conduct and identify the relevant papers for the literature review, we use the concept PRISMA. PRISMA is divided in three parts. First, the identification phase, the screening phase, and the last one, the included, that goes into our literature review for this paper. By the starting point, we use the database Scopus and as alternative databases, so that we have in the end 319 papers that we are used. By our screening criteria that we are seeing here, we have discluded 287 papers, so that we have in the end only 33 papers for our literature review. We sorted the papers in two main categories at first. The first category was energy and building, and the other one are mobilities. Here in result 1, we identified from the 33 papers that 26 could be used with energy and building. And for this part, we also do subcategories that we also sorted the papers again. First are here the two that are seen as the local heat transition in focus, but here are the focus. At first one was more in policymakers, and the other part was more for energy planner and energy multi-utilities that I could find. Here you see the model proposed for some papers that we find that they are looked into it more on the acceptance and decision making of sustainable heating technologies, and the output that here are defined are the recommendation for action for political decision makers. Something similar is here also the model proposed analysis of the heat transition through energy communities in Netherlands that we find, and here was the outcome more the recommendation action in the local heat supply for them, because they are searching which energy technology or which heat technology should they use in the future. Another category that we have is planning aquifer thermal energy storages. Here where also the model proposed more analysis of well-placed ATS in city centers of the Netherlands, and to develop new planning and design rules for ATES. The last two categories are seen here on the slide. The first category was microgrid only for electricity, where we are seeing that the models have more the PV, battery, household building, and also substations. And here were two main focus. One was more for peer-to-peer electricity market with prosumers, and the other part was more analyzing the local grid with prosumers and consumers without the peer-to-peer connection. And for all these papers, you can say that the output was more to identification of the local control strategies and also market mechanism. The other part of these identified papers were more microgrid, where the sector coupling to the heat side is included, and here are analyzes prosumers for integrating heat pump or analyzing different heat generators in the heat network, or also a market mechanism for the use of autonomous decision making also in this paper. But all of them are looked more in detail as an output to optimize the operation of the heat supply in the local energy system. The second result showed us the papers for mobility, and here we have the subcategories park and ride, where are analyzing a park and ride service system for specific areas in Japan, and the outcome here was to recommendations of the fleet size for a specific waiting time, in this case 15 minutes. The other next category was more in microgrid with battery electric vehicle. Here are the model proposed for analyzing microgrids and charging with price signals, or also for self-consumption with solar. And here was the outcome to investigate the battery electric vehicle and charging and discharging, and also the behaviors on the local power grid. The last category was charging station and charging characteristic. Here are more the model proposed to analyze the charging locations by different charging stations that are used more in normal or also on fast charging mode. And here are also looking more in detail for the outcome for the charging infrastructure. The last question that we looked into it was which agent-based modeling platform were used in all these studies. And here we can see that most of the studies didn't tell us which platform we'll really use. For energy and building sectors, NetLogo is a mainly tool that is used, and here you find some tools that are created by its own, like Agent Workbench or also Flexable or Smart Stabilities, or you also have tools like here from the provider MATLAB. There's also used as a software. So we see various platforms are given. So what are our lessons learned from all these papers? And here we could say that ABMs are widely applied for various topics and intend to offer decision support to energy communities, energy companies, urban planners, and also policy makers. And here are a few examples again from this, what I've presented before. We have here heat transition, for example, how our energy communities are formed, what conditions let them choose specific technologies, so that they look into it, which heating system should I use for the future when I didn't want to use gas anymore. And also here another part for aquifer thermal energy storages, where also topology and scale of new heat grids to exploit the heat storage potential of ATES, that is here included. And for the mobility, here for example, what size is necessary for autonomous car sharing fleet to limit waiting times, like 15 minutes, what is here analyzed. So here you see also different questions that are followed. Most of the studies in our review portion to a specific local area that serves as a case study. Here are mainly used from the researcher own data or also geographic information systems that are used. What we can see is that most of the studies used a bottom-up model. For example, each agent represented a household or plants like CHP, heat pump, heat grid, heat storage, and interacted together. Also, the local energy market is implemented, or local control strategies that are implemented. And we see also different types of models as well in this studies. We have only simulation models, we have also hybrid models where we interact with the real world, like by the car sharing in Japan. Also optimization models where we include for the heating technologies to scale up schedules, and accounting models where data are prepared before the simulation and also after the simulation. Something that I find really interesting is that some studies show that balancing the local power grid becomes more complex with an increasing regional expansion of renewable energies. And in this case, the external grid must help more with the balancing the local imbalance. And when we are looking into this, the question arises of optimization, the relationship between the generation, capacity, storage options, and also flexibility consumers in the local energy system. In addition, the heat sector and battery electric vehicle could play a significant role in this balancing mechanism. We also find some gaps for our lessons learned. One is the unknown ABAP platforms that are not really described in these papers. What we also missed is an overall systematic approach for neighborhoods that integrates the sectors building, electricity, heat and mobility. Something that also is missing is a transformation to the climate neutral neighborhood and the changes in the relationship between generation, capacity, storage option, and also flexibility pro and consumers in the local energy system. And last but not least, the future changes in the traditional roles in the energy system between energy communities, utilities, grid operators, and consumers. Based on our findings from the lessons learned, we set up an integrative ABM platform with all the parts that we are seeing from the papers. First, we have here a data source layer that is also given, where we have techno-economic data, social cultural data, environmental data, and energy transition scenarios that are included. And after that goes everything into the simulation, we get also a defined output, and with key performance indicators that are defined, we can look into different simulation scenarios and can also look into which scenarios are working. And from our findings, we find also the types of the agent, like a simulation model, hybrid model, accounting model, optimization model here as well. And the bottom-up model that I've told in the beginning, you see it here. We have here all the components like plants, VPV, battery electric vehicle, so the electricity side, the thermal side with solar thermal or heat storage in one building that can be in there, and also the interaction between other buildings where you have electric substations or thermal substation as a connector. Most of the time on the heat side you have a local energy system with different heat supply techniques that are included, and for that, to control all these parts of agent, you have maybe a system operator where you have your control strategy algorithm, or you have the energy trading platform with the energy market, or the scenario manager for where you can fill all the necessary data that has to be implemented in the simulation, the optimization model where you can generate your schedules for the different plans, or the accounting model where you have to prepare the data before the simulation or after the simulation. Here now my conclusion. This paper analyzed and present a literature review of the use of agent-based models in analyzing of urban neighborhood energy systems. We proposed a concept for an ABM that integrates all energy sectors, electricity, heat and mobility, based on the literature that we find. We identified two main research questions as well for my PhD that I want to follow later. First one is, how can energy communities meet local needs while at the same time supporting the overall system on the energy? How do existing neighborhoods have to change in order to actively support the energy system on the one hand and to achieve the defined climate targets in the sector on the others? Thank you for your attention, and if you have questions you can contact me. Here you find my contact data. Thank you and bye.